So the answer to this is carbon dioxide is low at the surface because at the surface you have lots of photosynthesis happening. And again, photosynthesis consumes carbon dioxide. The reason you have more photosynthesis at the surface is photosynthesis needs light, and you have sunlight at the surface, but then eventually that light is going to go away. Once you get deep enough, there's no light left, so you will not have any photosynthesis at depth. But at the surface, lots of photosynthesis that is eating up all that carbon dioxide. There's also respiration at the surface, but there's also a lot of photosynthesis eating up that carbon dioxide. But as you go down into, there's less and less light, so there's less photosynthesis, but there's still respiration, and respiration creates carbon dioxide. So that's why the carbon dioxide is increasing, because respiration is still producing that carbon dioxide and it's no longer getting sucked up by photosynthesis because there's no light. So that's why carbon dioxide kind of increases as you get deeper and deeper, because there's lots of respiration, but no photosynthesis in the deep because there's no sunlight. So in general, if there's like more photosynthesis than respiration, you'll have more oxygen and less carbon dioxide. If there's more respiration than photosynthesis, you'll have more carbon dioxide and less oxygen. Next up, let's talk about acidity. We measure acidity with pH. So pH is a measure of hydrogen ions. If you have a low pH, that is very acidic. So if you look on this little chart here, the lower pHs, you have things like lemon juice, vinegar, battery acid. If it's a high pH, that means that that solution is basic. So this is things like bleach and lye and ammonia have these high numbers around 13 or 14, and they are very, very basic. Now, the pH of pure water is 7, which we call neutral. That's that value right in the middle of this chart, 7. That's pure water. That's neutral. The average pH of the ocean, the average pH of the seawater in the ocean. Oh, I'm sorry. I'm trying to lower my hand. The average pH of the water in the ocean is about 8.1. So you can see it's actually a little more basic than pure water. It's slightly less acidic. However, the pH of the ocean is currently going down. The ocean is becoming more acidic. The pH has decreased by about 0.1 in the last 200 years. Now, that might not sound like a lot, but usually the pH of the ocean is super steady, like it's right around 8 and it doesn't really change at all. So most organisms are adapted for like the pH being exactly at 8. Most of them are not very well adapted to changes in pH, but we are seeing this decrease in pH. And this is called ocean acidification. I think a lot of people, when they hear the term ocean acidification, they think like the ocean water is going to like burn you, right? It's so acidic that it burns you. That's not at all what we're talking about. And in fact, the ocean is still less acidic than pure water. So it's not that the ocean is becoming acidic in a way it's going to like burn you. It's becoming more acidic than it used to be. And that is a problem for certain organisms. But why is this happening? It's happening because carbon dioxide reacts with water to make carbonic acid. So the more carbon dioxide you put into the water, the lower the pH, the more carbonic acid there is, and the lower the pH gets. So the reason we have ocean acidification happening right now is, of course, we are putting more carbon dioxide, primarily through burning of fossil fuels. We're putting more carbon dioxide into the atmosphere. That means that more carbon dioxide is going into the oceans, which makes the oceans more acidic, having a lower pH. This is particularly a problem for any organisms that make shells, because shells are built out of calcium carbonate, which will basically kind of dissolve in water that is even slightly more acidic. So we things like pteropods, which are these little kind of planktonic snails that are an important food source for a lot of different animals, foraminifera, also corals, right? Corals build a calcium carbonate skeleton. So for any of these guys, it becomes much harder for them to build their shells. And we will see like population declines because they're not able to build their shells as well. Corals aren't able to build reefs as quickly because it's basically a little harder to keep that calcium carbonate from dissolving in the water. So that's kind of why ocean acidification is a problem. Again, not because it's going to like burn your skin, but because it's very detrimental for these like shell building organisms that are important in a lot of different food chains. So Remember, this is what the depth profile of carbon dioxide looks like. It's lower at the surface, it's higher at depth. So, next question for you guys. What do you think the pH depth profile looks like? And I'll give you a hint here. Remember that a lower pH is more acidic and a higher pH is less acidic. So do you think pH will be high at the surface or low at the surface and high at depth or low at depth?